Hello and welcome again to our channel. And today we are going to discuss about the second part of our partial differentiation, which is the types of differential. In the previous video, we have discussed about what the differential is, how we can define the differential mathematically. Now we are in a position to discuss the types of the differential that is widely used in almost every branch of physics. And like in thermodynamics, there is a very widely used of the partial differentiations and this particular differential. So it's a very wide range of applications. That's why it is also very important to learn this in our this particular series. That's why I have included this particular differential topic in our series of the mathematical physics. So now let's start our video on discussing about the exact and inexact differential and what that is mean physically or mathematically. What is the meaning behind this exact and inexact differential? So in the previous video we have defined how we can define a differential. So a differential, let's say du is defined as du divided by the here is not du, is a partial derivative. It's not a normal derivative. So here is the partial derivative of u with respect to x dx and plus partial derivative of u with respect to the y dy. So this is how we can define the differential of a particular function. Here u is any function. So let's say u of x y is any particular function which is dependent upon both x and y. That why I uses this particular differential partial derivatives. Okay, so now there are two types of the differentials. There is exact and inexact differential. So let's imagine another function. Let's say there is a function z is a function of x and y both. So suppose that z is a function. So here we have taken a particular function which is zxy. So let's take a differential of this particular function. So the differential of this particular function will generally become d of zxy. Okay. So what's the meaning of exact and inexact I am telling? So if there is any type of differential, let's imagine I have taken dzxy as let's say x dx plus y into dy. Okay, so I have imagined that this is any type of a particular differential. This is here I have made a thing. You see that this particular expression and this particular equation number 1 and this particular equation number 2 are similar. Yes, what I have done is that del u by del x is I represented by x. Maybe there is a function xy or whatever which when differentiate gives x, and when we differentiate this particular z function with respect to the y, we get y into dy. Maybe this is a thing. Okay, so the thing is that I have taken this particular differential. So how can I classify this particular differential in exact and exact? So suppose that if someone asks you to find the particular function zxy from this particular differential, if someone asks you to find the differential or the particular function from which that particular differential is obtained, how you can do that? There is a very simple things. You just integrate it on the both sides, and integrating on both sides, what you will give that particular zxy function. So if you do the integration of this any type of the particular differential, and if you do the integration of this particular differential and you get the directly function, you directly got that particular function from which this particular differential is derived, then this is known as exact differential. It means the integration of this will be zxy is equals to Here, this is x into dx, and here is y into the dy. So here, there is a small mistake while defining the differential, that here x into dx plus y into dy, so I will interchange this. Yeah, this is possible that you can put this out here, but for beginners who do not understand this, I will type it here x dy. So I am again saying the previous situation was also possible, but for an absolute beginners, I will assume that whole y terms and x term vanishes when we just do the differentiate this particular dz xy. Okay, so just to forget about that, now moving towards this particular thing, that you define this particular differential, and when you just integrate this particular differential, you exactly get what type of function, or you can say that what type of previous function is there, and when you again do the differential of this particular function, you exactly get this particular differential back. So what I am trying to say, that just I have taken the example, maybe this is not true, but I have only taken the example that suppose that there is a function, any function, let's say u. Okay, so u is a function, or if you may define the differential of du xy as x into dy, I'm just taking the example, okay, plus y into dx. Okay, so this is the differential of a particular function. It means a small change of this particular function in x and y direction both. But when anyone tells you that from which function you define this differential, if anyone tells you to find out the particular function from which you have derived this particular differential, so what you do is that you just integrate this particular. And when you integrate this, there are two possibilities. Maybe directly integrating the differential can give you that what exact function it could be. Maybe it is xy square, yx square. I'm just assuming xy plus c plus whatever this particular thing is. The main concept is that there are two things. When anyone asks you to define the function from which you have derived this particular differential, what you will do is that you know the integration, how you can do the integration, the usefulness property of the integration. You just integrate on the both sides and you will get out that particular function. Maybe the function uxy is this, and if you just differentiate this function again, you will again get this particular differential. So there's on a reverse process. There is also a reverse process. How do we get the function from the differential, and how to get the differential from a function? So now we are understanding how to get the function from this particular differential. So there will be maybe two possibilities, that the so there may be two possibilities. First of all, you can directly get that particular function from the integration. And if you do not get the directly function from integration, this means that differential is inexact. So now I may define that if a differential, exact differential, so ed I am writing exact differential. Okay, so maybe there is a function uxy, maybe there is a differential duxy is equals to x dxy plus y into dx. And if you get that particular function directly by integrating, you get that particular function. This type of differential that shows this property is known as the exact differential. Maybe this is xy plus constant, I'm just assuming, it is not correct maybe, but I'm just assuming. So what you have learned, that when you get this particular function directly by integrating the differential, that type of differential is known as exact. You can remember, it is very simple. Exact means you can exactly that goes down to this particular function from which you have derived this particular differential. That type of differential is known as inexact. Maybe Okay, so this type integrals is exact, and second is the inexact differential. Inexact differential, I have written ID or IED, inexact differential. So what is the meaning of the inexact differential? This means that you may define another differential d of s xy. There is a differential. There may be any type of things. Maybe this is equals to the xy dy plus y x square dx. Okay, so maybe there is a thing. So there is another differential, and if someone asks you to again find out that function from which you have derived this particular differential, you will integrate. But what you saw is that after integrating, we have not got that type of function correctly. So it means this type of differential is known as inexact, in which by by directly integrating the particular differential df, you can't get the particular function f of xy by directly integrating. There must be some other methods to find out that, which we'll discuss in the next video, to find out that function. So remember, any type of the differential which by directly integrating gives the function accurately, that type of differential is known as exact. And if a differential do not get that particular function by integrating the differential, so that type of differential is known as inexact. Simply, inexact means it is not giving that particular function from which you have derived this particular expression of differential. So that type of differential is known as exact and inexact. But how you can find out which function is exact, which function is inexact, in a very simple manner? So there is a very powerful tool for this. So suppose that let a particular differential df, okay, so df is equals to the a, where a is some function of x and y, ax dx plus by bxy, because b also function of x and y both, x and by dy. Okay, so if there is a particular differential written in this form, oh, so how you can relate these two particular differentials? So axy is what equals to the y in this particular definition. So I am only correlating so that you can understand it better. So here you can see that I have defined a differential. Okay, so if I have defined this particular differential, so okay, so I have defined this particular differential. Or how, if someone asks you to exactly find out that this differential is exact or inexact, so there is a very powerful thing you can do. If, mark my words, this is very important, if the partial derivative of a with respect to y is equals to the partial derivative of b with respect to x, this means that the differential is exact. The differential is exact. Again, if the partial derivative of this particular axy function with respect to y is equals to the partial derivative of b function with respect to x, so this type of property, when a differential is showing, it means this is an exact differential. This is an exact differential. And if this property is not true, so this basically means that this is inexact. It means if partial derivative of a with respect to y is not equals to the partial derivative of b with respect to x, this means, so this means that the differential is a inexact differential. IED means inexact differential. And if this is equal, this means is an exact differential. And this is a very easy to find out which differential is exact and which differential is inexact. So maybe in the next video we discuss more about the deep of the partial derivatives, that how we can change the variables in the partial derivatives, which is a very important thing. Okay, and also doing some of the questions in the partial derivative is very important, so that we know that how to check our accuracy and the concept building on that particular question. So in the next video we are going to discuss all about the advanced topics in the partial derivatives, and do some of the very important questions in the partial derivatives. So thank you for watching my video of mine of exact and inexact differential.